Welcome to the Explainer. Okay, let's dive right into this massive geological marvel and uncover exactly why the Pacific Ring of Fire experiences the vast majority of our planet's most extreme natural events. If you've ever watched the news and wondered why so many devastating earthquakes and giant volcanic eruptions always seem to happen right around the edges of the Pacific Ocean, well, you are in exactly the right place. We're going to break down the incredible subterranean engine that actually drives this whole phenomenon.
So, let's start with a pretty staggering data point. Get this, an unbelievable 90% of all earthquakes on Earth happen right within this one specific zone. And we aren't just talking about tiny, minor tremors here. The vast majority of the world's absolute largest, most catastrophic earthquakes originate in this very region. It's a hugely active area.
And it absolutely earns that fiery name when you realize this zone also contains 75% of all the world's active and dormant volcanoes. So nearly all the earth-shattering quakes and 3/4 of the entire planet's volcanoes are concentrated right in this one boundary. But to really understand why that happens, we first kind of have to unlearn a few things about what this region actually is.
Section 1. The Horseshoe of Fire. Not a perfect ring.
Because, the name itself is actually a bit of a trick. Despite popular misconceptions and, of course, a very catchy 1963 Johnny Cash song, it is definitely not a literal ring. Nor is it just a single uniform fault line neatly wrapping around the ocean. The reality is that it's shaped much more like a giant 25,000-mile horseshoe. It stretches from New Zealand up the eastern edge of Asia, across the Aleutian Islands of Alaska, and then all the way down the western coasts of North and South America. And rather than being one continuous crack in the Earth, it's really an extremely complex puzzle of interacting tectonic plates.
Section 2. The tectonic puzzle, Earth's inner engine. To really get what's happening, we have to look at how these massive slabs of crust fit together. The Earth's tectonic plates aren't just static. They're actually floating on top of a layer of solid and molten rock. And as they drift around, they interact in three primary ways. They pull apart, they slide horizontally past one another, or they violently collide. Let's look at how each of these plays out in the Ring of Fire. First up, we have divergent boundaries. This is where tectonic plates are actively pulling apart from each other. A great example of this is the Gulf of California. Down south of the US-Mexican border, seafloor spreading is literally ripping the Baja California Peninsula right away from the Mexican mainland. As the plates pull in opposite directions, magma wells up in the rift and cools down to create brand new crust.
Next, we've got transform boundaries. Here, the plates are sliding horizontally past each other. Now, these generally don't create volcanoes, but wow, are they incredibly dangerous. Because the edges of these plates are rough, they often get stuck. Immense stress just builds and builds over time as the plates keep trying to move. And when that rock finally breaks or slips, it violently snaps forward, sending massive shockwaves right to the surface. We call those areas of breakage faults.
A really famous real-world example of this is California's San Andreas Fault. Measuring about 800 miles long, this is a highly active zone born from the North American plate moving south while the Pacific plate pushes north. In fact, it was movement along this very transform boundary that caused the devastating 1906 San Francisco earthquake.
Section 3. Power of subduction, fueling the fire.
Now, this third type of movement. This is the true powerhouse driving the ring's infamous volcanoes. Convergent boundaries happen when tectonic plates crash directly into each other. But they don't just crumple up like a car crash. Usually one plate is heavier and denser than the other. It's the geological recycling happening deep underneath that crash site that fuels all the fire up above.
We call this process subduction. When these plates collide, the heavier oceanic plate gets shoved downward, slipping right under the lighter plate. This creates a massive, super deep trench on the ocean floor. And as that heavy crust gets pushed deeper into the incredibly hot mantle, it actually melts into magma. That new, hot magma then rises back up through the crust, eventually bursting right to the surface to form strings of active volcanoes.
If you were to, say, magically pull a giant plug and drain all the water out of the Pacific Ocean, you'd perfectly see this cause and effect relationship written right into the Earth's geography. Massive, deep oceanic trenches run exactly parallel to the volcanic arcs they create on the surface. For instance, the Aleutian Trench runs right alongside Alaska's Aleutian Islands, which, by the way, boasts 27 historically active volcanoes. Down south, the Peru-Chile Trench runs parallel to the towering Andes Mountains, home to the world's highest active volcano.
Section 4. Famous fiery giants, historic eruptions. Let's ground all this science in human history for a second, because the sheer volume of volcanic activity here is kind of hard to wrap your head around. The National Oceanic and Atmospheric Administration estimates there are more than 450 volcanoes dotting this incredible 25,000-mile stretch. That is all the way from the southern tip of South America, up across the Bering Strait, and right down into New Zealand.
When you trace back through history, these specific tectonic boundaries are responsible for some of the most devastating natural disasters ever recorded. I mean, in 1883, the island volcano Krakatoa in Indonesia erupted so violently it destroyed the entire island, sending ash 50 miles into the air. In 1960, the largest earthquake ever recorded struck Chile. We've seen Mount St. Helens erupt in Washington in 1980, and of course, the devastating 2011 earthquake and tsunami in Japan. All of these originated right along the tectonic boundaries of the Ring of Fire.
And listen, this isn't just ancient history. The threat is entirely ongoing today. Take Popocatépetl in Mexico, for example. It sits on the Trans-Mexican Volcanic Belt, which was formed by the small Cocos Plate subducting beneath the North American Plate. This highly active volcano sits right near Mexico City and Puebla, meaning it poses a direct risk to more than 20 million people living right in its shadow.
Section 5. Earth in Constant Motion, a Living Puzzle.
So, after witnessing this staggering scale of destruction and creation, what should you really take away from this explainer? What does the Ring of Fire actually tell us about the planet we call home? Well, the crucial point is that our planet's crust is not permanent. It's so easy to look at a map and think the continents are just locked in place forever. But the Ring of Fire proves that the Earth is a living, breathing puzzle. It's continuously shifting, tearing itself apart, and completely reshaping itself over millions of years through the relentless engine of plate tectonics. I'm going to leave you with this final thought. As the Pacific Plate continues to grind against its neighbors, generating both terrifying destruction and brand new land masses, the map of our world is slowly being redrawn. If the very ground you're standing on is in constant motion, how completely different will our world look millions of years from now? Thanks for joining me on this explainer, and keep exploring.